So today we're quite happy to welcome Dr. Paul Bierman. He's a professor at UVM, the University of Vermont, the Gund Institute for Environment. He is a geologist by education and training. And he's going to talk about the latest find, especially of what happened to Greenland sometime in the past million years. Paul also, interestingly, just published this book, and I don't know, because he's screen sharing, if you can see, it's called When the Ice Is Gone. Really interesting book about really this entire project, I would say. Because one of the things that impressed me when I came sort of from the State Department policy world into more of the cryosphere climate world was the degree of incredible international collaboration, cooperation that you see in these kinds of projects. There are very few people that focus, say, just on Greenland or just on glaciers or just on Antarctica. It's really very cross-cutting. But I would say that this particular story goes more broadly than even that norm. Not only Vermont, Denmark, Greenland, Australia, really brings a lot of different people together that Paul will talk about, both in terms of the study, but also in terms of how it happened, and if we have time, the process of writing this book. So, Paul, really happy to have you, and we'll let you take it away from here.
Thank you, Pam. Can everybody hear me okay?
Yes, hear
Yes.
you and
Great.
see.
Okay, so one caveat here is on Sunday, I woke up with COVID, and thank God this talk was today and not yesterday because I actually have a bit of voice back. Hopefully I will make it through the next 20 or so minutes. All right, so I want to jump right into the science and our findings. And up on the screen here is a photograph that we actually took in 2019 from the first piece of sediment that we melted from the bottom of the Greenland ice sheet. This was collected under Camp Century. And the data from this were published in 2021 and 2023. And I've talked about that before, but the big picture finding of this whole talk is that we have pulled macrofossils, insects, wood, twigs, moss, seeds, soil fungus from now not only one place under the Greenland ice sheet at Camp Century, but as of this summer, two places, and that's GISP 2. Yeah. And I just want to put the map up, and can you see my cursor moving as I move here?
Yes.
Okay, so Camp Century is this little white dot up in northwestern Greenland. And the work that we did in between 2019 and 2023 showed that it had deglaciated about 400,000 years ago. The work I'm going to spend a lot of time talking about today is from Summit Greenland at GISP. And these are really different because to deglaciate Camp Century, you don't have to lose the Greenland ice sheet. You can notice this model that 50% ice loss deglaciates Camp Century, even less will. But to deglaciate Summit Greenland and GISP 2, you have to lose between 90 and 95% of the ice sheet. And so that's the real take-home message from today's talk. Okay, so the first photo was the fossils from Camp Century. These are the fossils from GISP 2 at the center of the ice sheet. The large spheres are soil fungus. The small spheres are spike moss. There's a poppy seed in here. There's a willow bud scale in here. Not shown are some pieces of insect parts that we found. So really, both of these places have preserved a tundra ecosystem. We'll back up a little bit and show you the Camp Century story. This is Lyle Hansen and Chet Langway, both incredibly important in recovering the Camp Century core in the 1960s. That is the sub-ice core that they're looking at. It's brown, it's frozen, it's full of rocks. The part they're looking at is glacial till, the material from underneath glaciers. And that's a photo from somewhere in the late 60s, most likely at Krell, given their jackets. That material had a long history through the United States, moved to Buffalo, and then vanished in 1994. Turns out it was well preserved and well frozen in Copenhagen between 1994 and probably 2018 or 2019. When the Danes refound it and I got to see it. That's me in the red hat there. If this were a video, you'd see me shivering because it's like minus 27°C in that freezer. And we're looking at those samples. Shout out here to 3 graduate students who've been working with me on this project. They are looking at the original Buffalo box there that held this material. between the mid-1970s and 1994 there in the freezer in Copenhagen. And this is what the material looks like when it's cut out of the core. For any of you who studied glacial geology, this is not an atypical material you might find in, say, a gravel pit. The sample was frozen, except it stinks because they drilled the core with a mixture of trichloroethylene and diesel fuel. And this is really the moment of discovery of these fossils. We had melted the sample, we had put it through brass sieves to separate the different size grains, the silt, the sand, the gravel, the cobbles. And then we were saving every last bit of this material because we only had about 700 grams for about 30 collaborators around the world. And so we were filtering. And if you look closely at this video, you'll see little black specks floating on the water there as we pour into this filter. And it turns out those little black specks are the fossils we've since analyzed. And so if you look at the filter close up here, the green arrows will point you to those fossils. Some of them are still floating on the water. Some of them are trapped on the filter here. This was the first sample we ever analyzed. So the core was photographed sometime before 1981, probably even much before that, intact. That's the black and white photo here. There were 5 sections to the core, and then they were cut up into sections and stored in those cookie jars. And this is the same photograph replicated in 2021 with the pieces that still exist. And you'll notice that there's only several pieces missing there in red here. 2 pieces are missing. There's been a piece that's been thawed in here, but the core is remarkably intact from Camp Century, and that's due to the efforts of 2 men. Chester Langway, shown here at the end of his career in the freezer at Buffalo with cores. These are die 3 cores. And J.P. Stephenson, a Dane who has maintained the ice core storage in Denmark for decades. And so the miracle is a core drilled more than half a century ago is still nearly pristine. And when we took that core apart, and most of the work I'm showing you here is Hallie Mastro's work. She's finishing up her graduate degree at UVM right now. There she is looking down a microscope. She found a whole series of different biological materials. And she's the botanist. I am not. I'm the geologist, and this is her slide. But from the upper units on the core, these are some of the things she found. This is a poppy seed. I know that much at this point. And what she's done is put together these photographs of the modern flowers and plants that generate the fossils that she found. And for any of you familiar with Arctic tundra, these are really very typical things you find walking around that would be scratching your ankles if you're walking in Greenland today, including this chironomid, this midge fragment that indicates it was an aquatic environment, which fits what we know. Probably this was a tundra with a shallow stream based on the sediments that we see. We know the age at which the ice sheet melted away at Camp Century, and we know that due to work in Tammy Rittenhauer's lab in Utah. The first data we published were from this pilot sample, 416,000 plus or minus 38,000 years ago. That's a really important time. That's marine isotope stage 11. It's a time of extended warmth around the planet, up to 30,000 years of interglacial conditions. Now, due to a person by the name of Hawk, who worked as a master's student with Tammy, we have 3 more confirming ages here, all within the overlap of the eras on them. So we know the uppermost part of the core here was exposed 400,000 years ago. And that means the ice sheet had to be absent. That it's unequivocal data at this point with 4 separate measurements in different places. We don't have a good history beyond that at Camp Century, but we do know, and based on Ben Kiesling's modeling that's shown down here, we do know that if the ice is gone at Camp Century, at least 1.5 meters of sea level rise has to happen because of melting in Greenland. But the model doesn't constrain the high end very well. It could be up to 6 meters of melting, 5.5 or 6 meters if Camp Century is free, because it turns out that Camp Century is a place that actually is rather difficult to melt away. So this is a science paper published last summer. Now, the takeaway message from this is that all of this happened with carbon dioxide levels in the atmosphere at or below 300 parts per million. So remember that as we keep going. Okay, so in 1993, United States drilling team completed the ice core at GISP-2, and they drilled 1.55 meters into the base of the glacier there. Again, GISP-2 is here. Camp Century's here. This is some footage that Mark Twickler provided me just a couple weeks ago, and it is of the drilling dome at GISP-2, and the driller is removing, in this case, an ice core. He hasn't provided me the removal of the sediment core beneath, so this is the ice coring rig. And you'll see them then bringing out the long core of ice here. They're all wearing respirators because they were using a chemical called butyl acetate, which is toxic, although probably less so than diesel fuel and trichloroethylene. And they're also wearing raincoats to keep the butyl acetate off them inside the drill dome. So I'm going to focus on the bottom of the GISP-2 core. And there was glacial ice, and then there was about 13 meters of silty ice in here. We analyzed that silty ice in a paper back in 2014. And the carbon and the nitrogen in there suggested to us, as well as the beryllium-10, that there was soil beneath there. But we didn't have the soil, and we couldn't analyze it. And a couple years ago, after we worked on Camp Century, we went back to the ice core facility folks and said, we're looking at these logs, and there's 8 centimeters of till underneath boulders. Where is that till? And they looked around, and it turns out the till had been shipped to Australia. It had been dried, it had been exposed to light, it wasn't kept frozen, but they had some baggies of it. And so they sent us baggies of this till. And this is a diagram in a Weiss et al. Paper in 1997. And you can see that small layer of till below what they called erratic boulders, underneath which they termed the rock granitic bedrock. It's rock, it may well be bedrock, but it may also be another large erratic boulder. The measurements in here are actually incorrect, which is why the X through there. There's about 1.55 meters of total material in here, not of the rock below. So in 2016, Jörg Schaefer and colleagues published a paper after analyzing beryllium-10 and aluminum-26 in a series of samples in the rock below. This is the bottom of the core here, corresponding to that. And then their samples are in color here. They had to merge pieces of material to get enough rock to work with. And you'll notice that the upper 2 samples, 2 and 3, were merged, and in between them is the till. So we got this till with the idea of measuring the aluminum beryllium, which we did. That turned out to, in some ways, most ways confirm what Schaefer had done. So I'm not going to focus on the cosmogenic measurements, but I'm going to focus on the fossils again. These are 2 photographs of the till I'm going to show you. They both came from a woman by the name of Deb Meese, who was deeply involved in the 90s and early 2000s in this work. They were in her personal archive. And they show you what this material looked like. And that's a centimeter scale here. So here's one view of the till before it was unfrozen and melted and dried. And here's a view from the other side that really looks like till in a glacial gravel pit. Rock below, rock above, pieces of angular rock and a matrix of sand and silt in here. And that's the sample we worked with. But remember, it's only 8 centimeters. It's 3 inches. It's very, very little material. We had 30 grams to start with of this material. So we found, again, a whole series of fossils. And this is the paper from the summer in PNAS. It's just a brief report. Most of the fossil work in here is Halley's with help from Dorothy Petit and Ola Benecke. Barry Rock at the University of New Hampshire helped with the wood identification. And what we find there is in many ways similar to what we found at Camp Century. So poppy seeds indicate Arctic poppy. Megaspores of spike moss indicate this small plant that you might just crush underneath your foot. And the wood that we can identify is all from Arctic willow. And again, this is not the beautiful willow tree you might imagine if you're from the South, but scrubby little willow that you might trip on under your feet and around your ankles. And together, the paleobotanists and ecologists working on this believe the landscape in central Greenland looked something like this. And that's a helicopter for scale. Rocky, dry, very little sparse vegetation in here. The ice might have been nearby right after deglaciation. But now we have evidence from the center of the ice sheet of an ice-free time. We don't know the exact age, in part because of the way the sample was stored. It would potentially have been possible, but we don't know that without the sample to analyze this using luminescence the same way we analyzed the Camp Century sample. But since it's been heated and taken apart and dried and exposed to light, we can't do that. So let's put this in context. So from the Camp Century core, we know that Greenland's ice there in northwestern Greenland melted naturally at less than 300 ppm carbon dioxide. It melted at 400,000 years ago. That's in here. And there's the core, and there's MIS 11 at 400,000 years ago. And you'll notice stretching back a million years, carbon dioxide has never in the atmosphere been greater than 300 ppm. And this is the record from the Vostok and Dome sea cores in Antarctica. So we hit that level a little before 1950, and our current level today, of course, is far higher. As of August, when I pulled the information for this slide, it was 423 ppm. So we've taken the natural level at which Camp Century melted and the level we had before the Industrial Revolution, and we've added half again more carbon dioxide to the atmosphere. And of course, that's warming the planet and making, excuse me, Greenland's ice increasingly vulnerable for melting. And we are headed only upward at this point. So what we know right now is that Greenland was greater than 90% ice-free within the last 1.1 million years. That 1.1 million years is based on Schaefer's calculations from the GISP-2 rock, part of the core, but it's only a limit. Anytime within the last 1.1 million years, the center of Greenland could have been deglaciated. We know Camp Century was 400,000. We also know that CO2 levels were at least 30% less than they are today when this happened. So we could imagine a Greenland like this with very little ice. And this brings me back to Wally Broker and one of Wally's most famous sayings, that climate is an angry beast and we're poking at it with sticks. That stick is really one stick, it's carbon dioxide. But I'm going to scratch out Wally's climate and I'm going to replace it with Greenland. So Greenland is now the angry beast and we are poking at it with a very large carbon dioxide stick. So I'm going to switch gears here and put all of this in some context for you. So Pam mentioned the book, and if you want a sort of, I don't know, a review of the book isn't the right word, but I did a Q&A with the New York Times a couple weeks ago, and I think they did a really good job of sort of summarizing my thinking for the book and why it's there. But it was actually encouraged by an editor at Norton after we published that first paper in 2021. And so what I do in the book is try to set the context for these ice cores. And that means going back to understanding Greenland as a place, Greenland's people, the people who have inhabited Greenland, and the explorers and the scientists who work there. So I start with people like Alfred Wegener, who of course is better known for plate tectonics, but led a 1930s expedition to Greenland in which he perished, where 3 men survived on top of the ice sheet, living at the summit underneath the ice in a series of ice caves. Then I look at the strategic importance first of Greenland in World War II, but then in the Cold War, especially because that drove the science that's allowed us to take and understand ice cores, including understanding snow and its transformation, collecting ice cores, archiving ice cores. And it also drove the Army to build under snow camps, modeling themselves after Wegener's work, after a French expedition in the 1940s. This one's particularly fun because it was reported in a magazine that no longer exists, Real Magazine, the exciting magazine for men. But you know, this is obviously one of the military folks who was up on the ice dressed up in their furry hoodie. But I love the headline, which is, "We built a military miracle in the Arctic, our secret base under the polar ice." And it's full of great photographs and all kinds of descriptions. Of course, they don't tell you where those bases are, but this is what they look like from photographs at the time. They were giant tunnels made of corrugated metal. Some people called them giant sewer tunnels, and they had insulated buildings inside them and diesel generators. And for 3 to 6 years, depending on which of the 2 stations, men lived inside these. They were actually radar bases, but that's not what the public was told. They were secret bases under the ice cap. All of this was driven by a man named Henri Bader, Swiss-German, left Europe before the war, and then designed the US plan in the Arctic for scientific research, including transportation, shown here, and most importantly, the collection of ice cores. This is footage from the collection of the first ice core at a place called Site 2 in Greenland. They got down about 1,300 feet with this ice core, very poor recovery, but it's the first place that we demonstrated that ice cores are recorded history. Isotope history was recorded in there, stratigraphy of the snow and ice, density, and all of that. Luckily, The United States Archives actually had a Voice of America recording of Bader, so I'm going to play a little bit for you because I find this just really intriguing. This is the man who was the intellectual driver behind the entire U.S. ice coring and ice study and ice physics program throughout the late 1940s all the way through the mid 1960s. So let's take a listen to him. He's describing the first ice coring at Site 2, the video you just saw or the film you just saw of those ice cores coming out.
The purpose of deep ice coring is to get information on conditions deep down in the glacier. And since conditions are simplest on the high ice caps, this is where we have been drilling.
So it's kind of a fun time machine. That's his application for U.S. citizenship. That's his photograph. And then to actually hear the voice of a man who's been dead since the 1990s, but inspired all of this ice coring that we do. So the penultimate, actually, no, the ultimate American adventure in Greenland and sort of scientific achievement was building a place called Camp Century. This is the Popular Science cover from February of 1960. This was not a secret base, despite how much noise they made about it being secret. The US was really trying to make sure that everybody, particularly the Soviets, knew that we had a base under the ice sheet. There is some military use to this base in terms of testing out their ability to have trenches, run trains through them, and actually have a sort of nuclear missile shell game under Greenland that never came to pass. But there was an idea of running thousands of kilometers of tunnels under Greenland with nuclear tipped missiles that the Russians couldn't see. But construction work like this, it's called cut and cover. So they would cut through the snow and then they would cover the 20 to 30 foot deep trenches with metal forms. You can see that in this photograph up here, and then they put insulated barracks in. The metal forms were often removed because the snow blown on top would harden sufficiently. It had a full mess hall. These folks are making turkey, and it had unlimited frozen storage. And people went back several years later and were eating the fine steaks that were still frozen after the camp closed. But most importantly, it had this drill rig in a drill trench where the drillers could sleep in warm beds at night. The drillers had full power and scientific support. And it took them 6 years to get the core out. And the reason they had so much power is this. The camp was powered by a portable nuclear power plant. First one of its kind to be installed in the Arctic. It worked for several years before it was removed. So the power plant is no longer there. And this is what inside the camp looked like. And again, it's heated, it's lit. This is a 1,000-foot main street with trenches off either side that had housing and food and research and the core. And the Army loved to brag that there was infinite hot water for hot showers, for brushing your teeth, for washing your face, and even for shaving, although it appears that when you see the next clip, the soldiers had electric razors because there was so much power there. So this all ended in 1966 with the recovery of the core, and the base shut down immediately after the final drilling of the core. They would have gone further, but they broke a bearing in the drill, so they got their 11.5 feet of 3.44 meters of subglacial material. And then in the last publicity stunt for Camp Century, this is the ice coming off the ice sheet on one of these big wheeled vehicles down a gravel ramp in Northwest Greenland. In the last publicity stunt, Chester Langway, shown here in the middle, and Lyle Hansen, the driller, went to the Pentagon to thank them for the support to drill this ice core, which the New York Times actually covered with a headline called "Army Serves Drink Cooled with 2,000-Year-Old Ice." And they took the ice, they broke it up, and they dropped it into Coca-Cola. And if you look in the bottom corner of this picture, you'll see a microphone and some cups right below it. And apparently the Army brass drank Coca-Cola with bits of 1,000 to 2,000-year-old Greenland ice in it that went snap, crackle, and pop as the bubbles, which were compressed air from ancient atmospheres, popped into their soda. And then the Camp Century core, after a very important paper in 1969, sort of slowly dropped off the map. So I just want to finish by kind of looking back in time at what we think about climate change and the effects and what we learned from ice coring. So this is an advertisement that some of you may be familiar with, published by a company called Enco, which was part of Humble Oil, which ended up being part of Esso, and then Exxon, if you track all of this. But two-page spread in Life magazine. And the headline, if you can't read it, says, "Each day Humble supplies enough energy to melt 7 million tons of glacier." And they're proud of it. So I was born the year before this in 1961. And the text below says the giant glacier has remained unmelted for centuries, yet petroleum energy humble supplies, if converted to heat, could melt it at a rate of 80 tons each second. So in the 60s, we have an oil company proud of melting glaciers. We also have futurists who look at Camp Century and say, wow, maybe this is our future. This was published in the Sunday Comics in 1960, it's February 1960. And it is clearly based on Camp Century. It's called Cities Under Ice. Ice caps no longer prevent people from inhabiting the frozen wastes of polar regions. The ice itself may become a shelter for future settlements. And then it talks about Greenland and Camp Century. But if you look hard at it, you're going to see the ventilation plant, the solid ice roof. There are trains here. This is a freight line. There are fancy automobiles. There's a nuclear power plant. It's Camp Century on steroids with potentially thousands of people. So there was this very optimistic view of the future at that point. Well, the future we got is nowhere near as optimistic as I think all of you know. This is out of Mike Mann's book. It's a comic, and it just says, next anti-climate line, melting ice sheets lift all boats. And that's exactly what's happening today as the melt rate in Greenland continues to climb, and so in Antarctica. And the results, this is a photo of where I grew up in Baltimore, Maryland. This is the Inner Harbor during a king tide. But this kind of flooding of the pedestrian walkway here is becoming more and more common as sea level rises and as the mid-Atlantic states, due to what you might call a glacial hangover and the collapse of the glacial forebulge, are subsiding at a rapid rate. And we can look at a recent paper from Nature Climate Change that actually maps out the population in the US that is at risk from sea level rise of a little under a meter by 2100, which is not an outlandish view. There are people who would predict more. And the darkest orange here indicates somewhere between 100 and 200,000 people will be at risk in that particular, I think these are counties that are mapped here. And so if we look up the East Coast, there's a lot of orange on the East Coast. There's orange on the West Coast. There's definitely orange in Louisiana and Mississippi. So we are looking at millions of people in the United States potentially being affected by the melting of the Greenland ice sheet as it lifts all boats. And if you look globally, and you took the extreme case, which will take centuries to millennia, and you melt all of Greenland's ice, something on the order of 400 million to 600 million people live within the range of land that will be inundated if the entire ice sheet melts. And if we think we have a migration problem now, if we look forward and think about something like 1/16 of the global population being displaced because of rising sea level, then we're in trouble. So what I try to do with the book is to set all of this in context, to set the history, to set the drilling, to set the science, and then to look a bit toward the future, and to make the argument that keeping Greenland's ice frozen is really, really important for all of us around the world. Okay, a couple resources for you all if you're interested. That's the cover of the book. And the resources here are first campcentury.org, which is our website for the project. It's got all the science we've published. It's got the people involved, the teams involved. It's got some learning materials. We have a podcast that we've been putting together. There's a full-length documentary film that Kathy Kasich is finishing that should be hopefully in distribution next year, and at some film festivals later this year and early next. This is my personal website if you want to see more about the book and about what I do. And then this is our laboratory at UVM called the Cosmo Lab, where we do the isotopic measurements. And lastly, there's a QR code for Norton and their webpage for the book. So I think I have talked enough. I'm running out of voice, but I would love to take some questions from folks.
Thank you so much, Paul. It's great that your voice lasted this long. And I think we'll just go ahead and open it up for questions.